29,000 pounds of weapons, and Mach 2.5 speed represent the new F-15EX.
This war machine became operational in 2024 and is changing everything we know about air combat.
While everyone focused on stealth, the Air Force quietly built something faster and much deadlier than ever before.
This aircraft can carry more firepower than any other fighter in American history for modern air warfare missions.
5 game-changing capabilities make this aircraft unlike anything flying today in the global military theater now. Welcome to Jet Insight, where we bring you the real stories behind America's most advanced military technology.
So lesson. The F-15EX is a reimagined war machine that entered full operational service in July now.
Boeing's production line is building these aircraft faster than ever before to meet the expanding fleet demands.
The fleet is expanding, and first operational jets are already flying missions out of Portland National Guard Base.
This aircraft can carry 29,500 pounds of weapons, which is more than cars weigh.
The aircraft has 12 hardpoints across its airframe, holding up to 12 advanced radar-guided missiles simultaneously.
The F-35 carries 4 missiles internally when flying stealthy, but the Eagle II carries much more.
It carries Stormbreaker smart weapons that can hit moving targets from 45 miles away in any weather.
The F-15EX was specifically designed from the beginning to carry massive hypersonic weapons on its airframe.
F-35s locate targets while F-15EXs stand off at distance and unleash their payload. Mach 2.5 is the top speed, which is roughly 1,900 miles per hour in flight. EPAWSS is the most advanced electronic warfare suite ever installed, providing threat warning and countermeasures to pilots.
Cockpit area displays measuring 10 by 19 inches are all digital and customizable for the mission needs. The Legion pod detects aircraft by heat signature, allowing pilots to find stealth fighters that hide radar.
Redesigned internal structures support a service life of 20,000 flight hours for decades of active service.
Open Mission Systems architecture allows new weapons or sensors to be integrated rapidly without redesigned airframe structures. The F-15EX can control autonomous drones, spreading firepower across the battle space for total dominance.
The Weapons Systems Officer handles communications and sensor management, while the pilot focuses on flying and engaging.
Israel recently approved an $8 billion deal for Eagle IIs, proving its value to global allies.
Manufacturing precision components for the Eagle II requires rigorous quality control and advanced robotics on the line.
The laser scanning ensures that every engine component meets the exact tolerances required for high speed and power.
Automated welding cells increase the speed and safety of building the critical structural mounts for the engines.
Forging the primary frame components protects the airframe from the intense stresses of Mach 2.5.
Applying specialized coatings to missile casings ensures they remain operational in various harsh, high-altitude flight conditions.
Designing advanced avionics requires complex modeling of digital systems to achieve the desired combat performance for pilots.
Inspecting fuel systems reveals any microscopic leaks that could cause mission failure during sustained high-speed flight. Managing massive quantities of jet fuel requires specialized transport systems to maintain purity for the Eagle engines.
Logistics teams work around the clock to move critical engine parts to the field for rapid repairs.
Wind tunnel testing helps engineers optimize the wing surfaces for high-speed stability during Mach 2 flight.
Calibrating infrared sensors ensures that the Legion pod can accurately detect heat signatures against the cold sky. Manufacturing the complex data harnesses for the F-15EX involves miles of high-grade copper wiring.
Testing hydraulic systems ensures the landing gear can deploy quickly, even under extreme flight and landing pressures.
Producing multi-layer flight suits protects pilots from the extreme temperatures and pressures of high-speed flight.
The scale of Eagle II production involves thousands of workers and billions of dollars in specialized technology.
Maintaining a ready supply of fighters is essential for protecting national interests from any future air threats.
Cooling engine components correctly is critical to prevent structural failure under the heat of a jet engine.
Computer-aided design allows for the optimization of the airframe for maximum speed and minimal drag resistance.
Hardening titanium components is essential for the engine mounts to survive the vibration of high-speed flight.
Automated testing of cockpit displays ensures that every touch interface works flawlessly during a high-pressure mission. Rapid refueling systems allow the Eagle II to return to the air quickly during a sustained conflict. Laser alignment of radar elements ensures that the beam can track targets at ranges exceeding 100.
Recycling titanium scrap reduces the cost and environmental impact of the massive production of the Eagle II.
Installing the large area displays provides the pilot with an intuitive digital interface for complex mission data.
Pressure testing the cockpit canopy ensures the pilot remains safe while flying at 40,000 feet altitude.
Automated munitions transport allows the deck crew to arm the fighter jets quickly for immediate air combat. Fiber optic cables provide the bandwidth needed for the mission computer to process 87 billion functions. High-capacity cooling is necessary to maintain the processors that simulate air combat missions for the pilots.
Protecting the airframe during transport ensures that the aircraft arrives at the base in perfect operational condition.
Ensuring proper electrical grounding protects the sensitive avionics from interference and lightning strikes during the mission.
Storing sensitive electronics in a controlled environment prevents damage from heat or moisture before their final installation. Every switch and button is designed for intuitive use by pilots during the intense pressure of combat.
Proper tire maintenance is critical for the aircraft to land safely at high speeds on the runway.
Moving the massive fuselage through the factory requires coordination and precision to avoid any structural airframe damage. Gold-plated connectors provide the best conductivity for the high-speed data required by the Aegis network.
Robotic painting systems apply specialized coatings with perfect thickness to maintain the aerodynamic performance of the jet.
Testing fuel quality ensures that the engines operate at peak efficiency during high-speed and altitude missions.
Curing composite materials in industrial ovens provides the lightweight strength needed for modern high-speed fighter jets.
Automated vehicles increase the speed of the production line by moving heavy parts throughout the factory safely.
Regular software updates ensure that the Eagle II remains capable of countering the latest enemy air threats.
Providing continuous power to the production line requires large cooling systems for the industrial electrical infrastructure today. Stress testing ensures that the wing can withstand the intense vibrations of Mach 2 flight without failure. Automated foundries allow for the high-volume production of the General Electric engines powering the Eagle II.
Thermal insulation protects the airframe from the intense heat generated by the engines during the afterburner engagement.
Machining titanium requires specialized tools and high-pressure coolant to prevent the metal from overheating during processing.
Automation in the logistics chain allows for the rapid delivery of weapons to the squadron for combat. Virtual reality allows pilots and engineers to optimize the cockpit layout for maximum efficiency during intense missions.
Impact testing ensures that the cockpit glass can survive a bird strike during low-altitude, high-speed.
Advanced composite materials are essential for reducing the weight and increasing the range of future autonomous drones. Structural integrity is critical for the aircraft, and every component must meet strict aerospace quality and standards.
Tactical servers are hard
The massive industrial infrastructure of St. Louis is the logistical backbone for the Eagle II production line.
Semiconductor production is a national security priority for maintaining the technological edge in modern aerial warfare today. The future of national security depends on the industrial strength and aerial capability of the American fleet. Night operations testing ensures that the Eagle II can achieve air dominance in any lighting or weather. Regular software updates ensure that the Eagle II remains capable of countering any latest enemy air threat.
Drilling precision holes in the weapon's pylons ensures that missiles are held securely during Mach 2 flight.
Storing sensitive electronics in a controlled environment prevents damage from heat or moisture before their final installation. Moving the massive fuselage through the factory requires coordination and precision to avoid any structural airframe damage. Manufacturing precision components for the Eagle II requires rigorous quality control and advanced robotics on the line. Automated vehicles increase the speed of the production line by moving heavy parts throughout the factory safely. Every switch and button is designed for intuitive use by pilots during the intense pressure of combat.